In December 2019, the Chinese authorities notified the world that a virus was spreading through their communities. In the following months, it spread to other countries, with cases doubling within days.
The aim and objective of the presentation is to design a clinic incorporating passive techniques to run and access the clinic on thermal and energy grounds in IES simulation software.
You may have seen this chart since the start of the coronavirus pandemic. In one image, it appears to capture the state of each nation's battle in the global war against the virus.
New York was chosen as it was severely affected in the US.
This is Hard Island in New York City. For over a century, it served as the final resting place for people who were unidentified or unclaimed at the time of their death. More than 1 million people are buried on the island. The site is receiving renewed attention as coronavirus ravages New York, turning the city into one of America's largest epicenters.
The following is the site at the center of the Hard Island. Hard Island in the past had a variety of uses, starting from a getaway place to a quarantine station for both tuberculosis and Spanish pandemic, and lately used as a burial ground for COVID patients. The following shows the nearby clinics and hospitals in 10 km and 25 km radius. The entry to the site is through ferry and is within 100 meters from the ferry station. The following is a sun path showing that there's uninterrupted solar radiation to the site. The following chart shows the temperature range, where the highest temperature reached 33 degrees in June and the lowest is -12 in February. The following shows the wind rose diagram and wind velocity. It shows that prevailing direction is from south and the average high reaches 11 meters per second in March and average low 1.9 in July. The following chart shows the relative humidity versus dry bulb temperature chart. Highest is 81% in June and October, lowest is 55% in July. The green prim is growing in popularity. The cargo shipping container structures are used for green alternative and faster construction. The design was inspired from a cocoon where caterpillar molds itself to home with transformation to butterfly take place. Caterpillar has shown the change is possible and symbolizes hope and transformation. The hypothesis of biophilia has also been incorporated in this design. The clinic was designed incorporating all necessary spaces to satisfy isolation needs and treatment. The spaces required by doctors, nurses and staff, janitors and cleaners are as follows. To ensure proper care and treatment for the patients, the following spaces are provided. The plans as per the guidelines for design and construction of healthcare facilities and International Building Code, incorporating all the required facilities. For IES analysis, the following simulation set points were used. Stage 1. Containers were arranged in the following manner. It was observed that the concave gave the better results in solar gain to enhance passive techniques. As per the orientation, 30 degrees from the perpendicular gave better results in total energy. Stage 2 of the analysis, green assessment. ASHRAE standards were used to analyze the building, and the result is as follows. Stage 3. 3 passive techniques were used. Strategy 1, overhang. During summer, it prevents the harsh summer sun, whereas in winter, the low winter sun is emitted into the space, which results in direct gain. Strategy 2, natural ventilation. During summer, the prevailing wind enters through the operable windows and is exited by the stacked vents. During winter, the operable windows and the stacked vents are closed in order to prevent heat loss. Strategy 3, sun space. During summer, the high summer sun is protected by the overhang, and the prevailing wind enters the space and exits through the vent, which gives a buffer to the building. Whereas during winter, the low winter sun enters the space and charges the high thermal mass, which releases the heat during nighttime. The table summarizes the stage 3 analysis. Stage 3 summer scenario is summarized here. Stage 3 winter scenario is summarized here. Stage 4, 3 passive techniques were applied to the overall building, and the result is as follows. CFT analysis for the concept development. As you can see, the optimized case has lower wind pressure than the base case. The following shows a CFT analysis of the patient room, that is the care suite. A few renders of the project.